Hello everyone, in this video I am going to discuss about graphs related to zero, first and second order reaction from chemical kinetics. So for zero order reaction, the integrated rate expression is K is equal to A naught minus AT divided by T, where K is rate constant, A naught is initial concentration, AT is final concentration and T is time. And differential equation is equal to minus dA by dt is equal to K into A to the power 0. And this equation shows that the rate is independent upon the initial concentration of the reactant. So when we draw the graph between rate and concentration of the reactant, the nature of the graph is straight line which is parallel to the x-axis. So in this case the slope that is equal to 0. So when we draw a graph between AT and T, and we know the equation is AT is equal to A naught minus KT. So we have taken AT in y-axis and time in x-axis, and the slope is negative, and this is the straight line equation. So the nature of the graph is straight line, but as we know that the slope is negative, so the straight line, the nature of the straight line is downward in nature. Next, when we draw graph between T half and A naught, we know the formula T half is equal to A naught by 2K, and we have taken T half in y-axis and A naught in x-axis, and this is also a straight line equation. Y is equal to mx plus c, where the intercept is 0. So the nature of the graph is straight line which passes through the origin. So when we draw a graph between rate and time, then the nature of the graph is also a straight line which is parallel to the x-axis. Then next, first order integrated rate expression for first order reaction, that is equal to Kt is equal to 2.303 log A naught by AT. We can write also AT is equal to 2.303 log A by A minus x, where A is initial concentration, A minus x is final concentration. We can also write, as we know that 2.303 log, that is equal to 1 ln, so Kt is equal to ln A naught divided by AT. We can also write AT is equal to A naught into e to the power minus KT, and the differential equation for first order reaction is minus dA by dt, that is equal to K into a to the power 1. When I draw a graph between AT versus time, we know that the equation is AT is equal to A naught e to the power minus KT. So the nature of the graph is exponential in nature, as we know that y is equal to e to the power minus x. Here in y-axis we have taken AT, and in x-axis we have taken time. If I increase time, then e to the power minus KT decreases, so KT decreases exponentially, and this line meet x-axis at infinite, and this curve is also known as asymptotic curve. If we draw a graph between ln AT versus T, as we know that the formula ln AT is equal to minus KT plus ln A naught. In y-axis we have taken ln AT, and in x-axis we have taken time. So this is slope and this is intercept. So the slope is minus k, in intercept is ln A naught. If I draw a graph between log AT versus T, then the nature of the graph is also straight line, but as the slope is negative, so the nature of the graph is, here we can write AT, T slope is minus k divided by 2.303. And if I draw a graph between rate versus concentration for first order reaction, I know that rate is directly proportional to the concentration of the reactant. Here intercept is 0, and this is also straight line equation where intercept is 0 and the slope that is equal to rate constant. Next, if I draw a graph between rate versus time, I know that when time increases, then concentration decreases exponentially.